Alright. Announced in Twitter. Let people stream in to the stream. And get to work. So, last time we started working on networking, and we didn't actually do anything networky, although I did make sure that I'm linking SDLnet. But the focus is on teasing apart the server and the client's responsibilities. And just trying to get single player working with those teased apart responsibilities. So I did the hardest part of that last time, which was dealing with the terrain generator. So hopefully today we can wrap up running the physics in a different logical environment, and then start thinking about passing the data from the client to the server internally, not actually networked yet. And then farther down the road that becomes networked, and then the client needs to start predicting and all that fun stuff. And I'll have to actually set up an environment where I can run a server and a client, and then eventually two clients, and all that. Checking my volume. Yep. Okay, that looks fine. And yeah, I'll just give it another minute or two before I really start going to start talking about what I'm going to do. So what I can do though is this. So yeah, in the long run, in a real thing where they're in separate processes, there'll be two sets of physics running, the client physics and the server physics. But when you're single player, it doesn't really make sense to do that. And I was originally thinking that I would go ahead and do that while it was still in one process, just to get that stuff working. But that would then mean that in the one process, we would have to actually maintain two sets of physics data. And that is perhaps more work than it's worth for the sake of the thing that I'm talking about. Since that would just be a test, an intermediate test stage. So maybe I won't do that. On the other hand, maybe in the long run, for debugging, you really always want to be able to do that. So maybe in the same process, you want to be able to reduce to a single threaded mode and still test all your networking. Maybe that would make sense. I don't know. All right, I guess I have given it long enough. People who did not come in before now can cope. So, what do we do today? So, we need to do physics. We are currently generating the terrain. We've got this whole thing where we update the physics around the player, which isn't really correct yet in the long run for the server, but good enough for now. That's where we request it, and here's where we store it into our phys cache. So eventually the client will need to run its own physics, and so in a single process you do need to be able to get the physics data from either the server cache or the client cache. But since I don't actually want to have both caches in a single thing, there's a bug here. I thought about this when I was in the shower this morning. Because I originally started to just copy the whole MC, and that is probably the right thing to do because there's something I'm not copying currently. I'm not copying over the data that needs to free the physics data, which is Alex. So I need to copy that to make this work. So I'm just going to switch it to copy the whole thing to be on the safe side for the future. And then eventually we free it. When we overwrite an old one, do we free it? No, we don't currently. Oh, right. This is that whole allocation thing. All right, but I wanted to do that differently for the physics. Right. Right. So we need to free the old one. Let's just do that explicitly. You know, normally I talk about how memory allocation is easy. It's not a big deal. As a part of why garbage collection isn't really as useful as people think. And this may seem to give the lie to that, but this is multi-threaded nonsense. So yeah, sometimes you do have to do some work, and it's not a lot of work. So where do I free mesh chunk? Right, free mesh chunk. Let's do this. If no, let's use logic. If free mesh chunk physics data, and that just does this. Free mesh chunk physics. Let's see, and this line goes into that as well, and then this goes into our globals. And that's because I'm going to do it right here. Free mesh chunk physics. Physics cache MC, and that might be empty. So I want that to handle. Okay, so that should handle that. It was leaking before, probably. Yep. And I never moved around enough to see the leak, or maybe it would just be too much to ever see. So here we have this. We'll move around. I'm not supposed to free that, apparently. Oh, because we do it. Yeah, but see, that's wrong. That's freeing the physics data. Okay, so what we need to do is say MC dot Alex equals null. So this following thing can't free it, which is all kind of ugly hackery. But again, this whole thing about storing it in the mesh chunk. Oh, I don't need to do this. Reflex. This whole thing about storing the physics data in the mesh chunk is kind of a hack, so I don't expect that code to stay that way in the long run. But I should comment it, actually. That's that whole bad habit of not commenting. Yeah, okay. So let me actually do that one. So really, I could just have it take over the... Maybe I should do it like that instead. It's now the job of process mesh chunk to do it. And it can just do the whole free. No, it can't. No, well, I'll leave it that way. It's ugly, but... doesn't free them, it copies them. Alright. So... That fixes that bug, and then I just had another issue that I thought I would be nice to clean up now, which is that when we make a request here, so I have this whole chunk set valid, which is a separate set of flags. And I remember commenting that they were kind of redundant because it's just whether the chunk is actually null or not. But now we have an interesting thing, which is that the mesh only covers a 2x2 region, but it has to generate 4x4s so it can do the edge of the mesh properly. But for physics, we don't need the edge of the mesh. So what we can do is suppress the requests for all of that border chunks, which we don't need in this one. What was that called? Chunk, I've already forgotten what I called it. Chunk status. What was it called? Get chunk status. I must have just mistyped it. So no, wait, it's not. Yeah, okay, so chunk status is actually a mesh chunk status. It's not a chunk status, it's a mesh chunk status, right? So get chunk status alloc needs triangles. So if we have it, we do that. We call them abandon zeros everything. So we say if needs triangles is false, then we can set chunk set valid to true. On the borders, and now it won't bother generating them. And that might be all I need to do. Or it might cause some problems somewhere else, but maybe that'll work. Release gen chunk. Yeah, it tries to release them all whether they're null or not. So if mcs cs.chunk 0 of I. Wait, this is actually in the needs triangle case, so I don't even need to do that. I can just have this hard-coded to the 4 chunks that it does. Oops. But somewhere else, no, right, yeah, that's fine. That'll be the only place that frees them. Did the stream die? Yes. The stream is working for me. All right. So yeah, I think that fixed the only issue probably. So All right, so we can go ahead and commit that. Mix memory management of server physics chunks. And back to what the actual thing is here, right? Which is, okay, so right now we're keeping this physics cache. And so what I'd like to do is only use the physics cache for physics and not use the current cache in this stuff, which we can go ahead and actually not store them, I guess, in this path. So this one, I think it builds it directly, right? Yep, it calls build phys chunk. So let's find the other call to build phys chunk and comment it out. Oops. What? A hack that would allow you to escape the crash. Unfortunately, that's not specific enough for me to remember which specific hack and which specific crash. So that seems okay. And that'll reduce the memory pressure. Oh, nope. Free mesh chunk physics from free mesh chunk from set from render. So that something isn't being nulled, I guess is the problem. Which is odd because I would have assumed I was mem setting the mesh chunk to null. Build phys chunk. One of the reasons you comment the code out instead of deleting it is because now you can search for it still. So let's do Alex equals null, which is I know how that works. And then let's find generate mesh for chunk set. Oh, we're still recreating a new a new mesh maker every time. Should fix that. MC cast slot free mesh chunk is null. And then it's null here. I don't know what. Where do I allocate it? I'm looking. Oh, this is the old code. God damn it. No, it's not. Yeah, it is the old code. Right. Okay, right. MC. MC is malloc here, and I don't mem it. There we go. Gosh. Got totally lost. Now, the only downside of that is that we currently store the whole phys chunk in the mesh chunk. I guess we could back that out now. Because that's wasting a bunch of memory. And I no longer need it. Because I now am generating the phys chunks totally separately. Alright. So now if I try to do collision detection, it should totally break because I've no longer generating the phys data. So if I turn on collision, burp, yep, we die there. Okay, so now we just need to change gather collision geometry. To not use mesh chunks this way. So get physics chunk for coord. Right. Let's go defuncs. Get mesh chunk for coord. Get physics chunk for coord. And we'll eventually change this to use a different data structure. Okay, and then I have to implement it, which is in physics. No, is in server, because we're just going to hard code it to use this cache, the server cache for now. And what's going to eventually happen is this cache will get used for both the server and the client. So it will get renamed to something that's not the server cache. So we get the chunk. We get the clamped chunk. No, S physics cache x minus 1. We check if we get the mesh chunk MC equals phys cache of RYRX, and if MC chunk X equals RX, Y equals RY, we return MC. Otherwise, we return null. And if we return null, this has a fall through where it will just leave it set to 0. And it might be better to make everything solid so you don't just start falling. But if you do make everything solid and then I added physics that tried to push you up out of solid stuff, then it would try to push you up infinitely. So it might be better to do this. Bad equals false. Found bad equals true. And then we return whether you found bad or not. We return true if it was all good. And then we'll let the caller decide whether the right thing to do is to try to run with it even though it's bogus, or to wait for it to get loaded since it's being built asynchronously. Or we could synchronously force it to build. Maybe that would make more sense. Gather. Where's gather? Oh, it's only called inside here, I guess, for now. All right, so now let's see if that works. And now I have physics working again? Nope, I don't. Okay. Yeah, that was interesting because it kind of did for a little bit. I guess it has like one chunk that's valid, and as soon as I go outside that chunk, it's invalid, maybe. Chunk is what, 64, so not quite sure how far I've gone, but maybe I'm hitting around the limits of 64. I don't know. That was interesting. That's exactly what would happen when the physics data doesn't load. It's very different from in Minecraft because the two are always synchronized. There we go. All right, so go back to server, get physics chunk record. Oh, I guess we'll just watch it fail. See what happens to make it fail. Maybe it's falling too far and clip through the mesh. Nope. Nope, because the mesh is solid underneath, but the geometry is solid underneath, so. All right. This is the exact same bug I had when I did this stuff originally. It's the exact same bug. Checking against the index into the thing instead of checking it against the absolute location. I don't know why I keep making that bug. All right, so that should never trigger. one thing I didn't comment on when I did it yesterday is that I always have the physics chunks have higher priority than the rendering chunks. So you should pretty much never not have the rendering chunks you need. So here we go, work. Yeah, I still need to work on the physics so that they feel okay, but here we go. All right, that all seems reasonable. So now we pretty much need to put in some kind of primitive object system so that the networking has something to refer to. Because you don't want to just be sending camera coordinates or just hard-coded player coordinates. It's pretty much a waste of time to start implementing network packet types that aren't going to be the real ones, I think. So, all right. So, now, right now, we just have the client directly calling into the server. To do this get physics chunk record is technically server code. But as I said, this isn't really how it's going to work. This cache is going to be client code if you're client only. I mean, if you're single player. So this code isn't really server code, the physics cache. It just needs to be its own thing. So maybe I should actually do that. Is everything in here physics cache right now? Yeah, it is. So let's make a new file. Actually, let's just put this in physics. Since this is physics cache, this becomes physics cache feedback. And these S's become physics. And the prototypes become physics. Calls become physics. All right. And now the physics cache is incorrect because server, it's still calling it server here, and I didn't remember to extern it, so it didn't give us a link error. It just had 2 copies of it. All right. Yeah. All right. Alright, this is all still working fine and dandy. So, add. Oh, I didn't create a new file. Right. Physics cache to. Actually. What else did I change here? Okay, that was it. All right. So now we need to have an object system. So type def struct object. I didn't quite get time to eat dinner, so I'm gonna make a sandwich. That'll work. So the object system, what do we need? We need a vector. Position, a vector orientation. Do we need a velocity? Do we send velocities over the wire, or do we just send positions? We send velocities because then they can predict their movement. Do I already have a structure called this for the player? I seem to remember seeing a structure like this in main, maybe? Player objects. Yeah. Player object is a lot like an object, but it has a zoom. Yeah, that's probably... So we have to figure out how we're going to have some custom data for some object types, but not others. Maybe players are the only kind of special object because they clearly need to be special in the network stream. Git commit minus v will show you the diff as you're writing your commit message. Yeah, well the problem was just that I didn't think to do the diff. Like, it's not that there wasn't a command, it's that I had charged ahead. I guess if I got in the habit of always using that. But, let's see. Oh, I also didn't get the soda that I wanted to get. So yeah, so players need to be special, and maybe I can just say that the lowest 1K of objects are always player objects or something like that. That's a pretty low rant way of doing this, but OBBG can be a low rent thing in some areas. It's not like Minecraft is a particularly complicated game when it comes to objects. I mean, you obviously, you know, you want AIs and stuff like that, and so you will still have some kind of augmented data, but it'll be server only probably. So that can work in a different way. I'm sort of both thinking about what's this going to be like in the client code and what's it going to be like over the network. Kind of try to keep that in mind. So yeah, so this player object probably goes away because it's redundant to object except for the zoom. Do you need to know what other player zooms are, or is it really is that really just client side? I think the answer is that zoom is just client side, or it's gameplay driven. But if it's gameplay driven, then that has to be determined. It won't just be zoom. And therefore, this goes back to just being player zoom. And if it needs to be driven by gameplay state, then that state will have to explicitly update this global, or this code has to get rewritten. Oh, look. I'm supposed to do it there. The zoom is not actually being used at all, but if I wanted to, I could hook up something, say you right click and zoom in. So it's field of view. Let me get something to drink. All right. So where was I? Field of view, yeah. Well, that's what I figured you meant, but all right. So what do we got? Our server file is now empty. Yep. Right, because I'm making the object system. The object system is going to be shared by the server and the client code, so it's not. So it's not prefixed by anything. It's not going to have S underscores or C underscores. And it looks like this. Woohoo. There you go. There's our object system. No reason for that to be a power of 2, but whatever. So eventually we'll have player object mix. Okay, so now what else do? We need to allocate the objects. When we need to create a new object, we need allocator. And only the server gets to allocate the objects. So the client can have a stale opinion about the objects. So let's have a valid flag. And let's go ahead and have an object ID type so the code will be self-commented about the fact that things are objects. And we go ahead and have global access to this. And we'll never use object 1. So here's a terrible, terrible allocator just to get started. Now if this ever happens, what do we want to do? I guess we want to fail. So I was thinking we could crash, but probably not. All right, there we go. The power of 2 is convenient because it means that if I'm bit packing my network packets, I can always fit a player object into 10 bits in this case. Those are the rad type names. Have to leave work at work. Okay, that should be fine. Nothing's changed, so code will run. All right, so we have the beginnings of our object system. So let's go ahead and publish those. Need to sort this out at some point. This file. All right, so I don't really have a game start, so we'll just keep hacking this stuff in. There's a couple init functions. Whoops. I guess we'll add a world init. I guess I can put the world init in object. Well, it's not really part of the object system. It's really part of the world. Let's go ahead and have that. I don't even know what this file is going to be, but just go ahead and have it. So then it was called world init. And in world, we'll have obj ID player ID. Player ID equals allocate player. Now, in the long run, there won't be only one player, although in single player, obviously there will. So we don't want to get too attached to this. The client will have sort of a my player ID, but it'll get it from the server, and it may not be what you think it is. So now we got to go into where we have the player object, which is in main. It's no longer called that. It's called object player. And now we get rid of this. So we want to init the player's location, which we'll do here. So this is obj of player ID dot position dot x equals 0. And let's see what else was using player. Lots of stuff. I could make a pound define. I could pound define player to obj of player ID. I don't want to ship that, but let me just test that real quick and see if that just works. I want to turn on physics and try to collide with things. And yeah, okay. So I think that just works. All right, I'm just going to manually do the same thing. So get that in my cut and paste buffer. Player. Yeah. So we'll just go ahead and do it this way for now. All of this stuff needs to get abstracted different ways. Right now we could pass in an ID of what object space we want to be working relative to. We'll be able to have the physics run on arbitrary players or arbitrary objects. Wow, I have a lot of player. Oh my god. Alright, hopefully that was the last one. Oh. Well, I guess I can preserve that. This light should change over to using an object in the object system. Maybe we'll do that. It's a sort of a quick sidetrack, but just to be clear, in case I wasn't clear, this object allocator is temporary code. I'm never going to, in the long run, loop over everything. It'll build a free list and allocate in order one time. But for now, that's not a priority. I mean, maybe I should be flagging it. But I mean, I don't even free them currently, so... Alright, so... Hang on a second. Drink thing again. All right. So I have no idea what I was in the middle of doing exactly, but I think I had just gotten this player stuff working. So now the thing to do is to go to world. Let's actually, just so I don't have to loop over 65,000 unused objects, let's have a max, what's that object ID? Max, max player. And then why don't I make that in 32 so that I just don't get those. There's really no reason for it to be unsigned, because I'm never going to have 2 to the 32 objects. So object ID, where's object ID defined? It's up here. Let's make that signed. All right. And these probably need that cast as well, but int on every platform I use is in 32 anyway, so actually I can freely use those, but all right. So world, so physics main. Where do we do the physics? The player physics. Process take raw. Here we go. Let's just copy this whole function. And process take raw. It doesn't only. We're gonna have to change. We want the physics to be reproducible between the player and the server. So to do that, we're gonna change this to use a fixed time step always. Currently, this is a fixed time step some of the time, and then cleans up with that, which basically is a way to avoid tunneling, which I don't actually need with the current physics logic. So in single player, it's possible you could switch it to non-fixed time step, but fixed time step is just easier. It just guarantees reproducibility in a better way. Okay, so this is now it needs player space to world space. Okay. I'll move it because I think I won't need it here. So this is going to do the thing I was talking about. So this is obj space to world space, and it takes an object ID. It takes the output first, and then object ID, void. And we replace player ID with void. Sorry, player ID with void, and then probably shouldn't use the word world there. Okay, so then process tick raw is going to become the outer function, and this one is going to take an void, player physics, takes an object ID void, and void, and we replace player ID, replace player ID with void. Okay, and let's actually go ahead and say object O equals address of object void, and replace object void. Dang it, why do you not do that? I guess it's because it's out of the way, so it thinks that's a good thing, which it normally would be. So now that's just O arrow. Not much nicer. Okay, what have I not done? There's tons of stuff I haven't done, obviously, but so this process tick raw, everything moved over, right? It wasn't doing anything other than physics. It's updating the light. We have to say external flying because of that hack. Process tick raw. Okay, it looks like I still need player space to world space for the renderer, for the third person camera. So we'll leave that as ob space though. So this player space to world space, camlock, player ID. And then we need to process tick raw. Functions. And we call player physics of player ID DT. All right. Hopefully that refactoring works. Space. And then it looks like there's a bunch of pan defines I have to move over. Gravity. Is there a name for gravity? No, I must have just hard-coded that. Here's the... And then it's going to try to update the light, so... Is there not a light vel? Yeah, there's a light vel. Alright. Wait for now. Controls, that makes sense because somehow the server is going to have to find out what the player was trying to do. It's ob space now. Camera bounds. What do we do with the camera bounds? Physics move walkable. Oh, camera bounds is the player size actually. Bad name. Camera bound. Oops. So we'll just move it over. Render init is what says it. Let's just statically initialize it. just faster to type it than to trying to do all that cut and pasting. So yeah, doing networking is basically doing a ton of refactoring. Yes, I did use this here, so let's go ahead and restore camera bounds into this file as well. Make it static here. We'll resolve all that later. Make it static here. View xvel. Okay, so that's state, but it's for the flying camera, which doesn't really need to be networked because it's a debug camera. That's good to have 2 copies of that. And then the pending view is more control input. So we'll just, it's the mouse input. And we'll rewrite that to be explicit that all of this stuff is state that has to get sent across the network so that the physics can do the simulation. Lob space to world space already defined. Static. No, right, why do I need 2 implementations of that? That's really dumb. Oh, it's because I was going to leave it one of them on. Yes, we'll just share it. That's totally fine. We can move it into the util library. Alright, so anyway, so obviously the whole thing here is like still no networking. Nothing at all resembling networking. All I'm doing is refactoring all this code so the data lives in different places and is processed in different sequences and stuff like that. So we will get there. We will get there little by little. This is getting us to the point where it will be networkable, but it'll take a bit more. All right, so now what do we do? So, I have to do a bunch of changes, and it's just hard to remember everything I got to change. So, the thing to do is go back to the server and think about what does it take to make the server work, and what do I have to change to get us there. Obviously, it'll be a while before I have more than one player, but that's how that needs to work. So, max player. Yeah, let's change these to max player ID. Right, so now this works regardless of how many players we have, kind of. It's still got these controls and stuff that it needs to come in. Sure, I guess I might as well do that. It's got to get done at some point. So in one tick, what does the player try to do? They try to, this is a bit field. How do you network that? You don't really want to network the low-level mouse movement, do you? How do you do that? I don't know. This is what I was talking about yesterday when I was saying that not having done this stuff, I'm not necessarily making the right choices for how to network things. So if you want traditional FPS style mouse look, you can't network the mouse because the look has to happen instantly. And obviously you have to network it in the sense of networking what direction you're looking has to get sent across the net, but the server can't really be authoritative about which way you're looking. You get to look whichever way you want instantly. And so what that means is that your view directions are part of your input. They're derived from your mouse coordinates, but you don't update them. I guess that kind of works out the same, because if you send them across, as long as you don't lose them, the server will compute the same thing anyway. But that just feels more correct to me. Scrolling back through comments real quick just to see if I missed anything important. All right. So, what am I currently doing? Okay, right. So I'm putting these player controls in here. So we'll make the flying part of that, because maybe that represents some power that you turn on. And then this is part of the player state. So type def struct player state that the no, this is actually part of client state. Right. Alright. So we'll have to change how the physics works to make that work. Because that has to become part of computing these. Let's make these floats for now. We'll convert them to fixed point later when we network, when we're actually looking at the networking. So these are part of the client view physics. So void client physics GT. This is actually global. So what we want to do is pull out the part that relates to that, much like we want to pull that out. Let's just do that in process tick raw for now. Here it is. So I guess we just move this whole thing. This is everything to do with rotation, because you can see we're writing to ang and we're not writing to any other part of O other than ang. So it's okay to move this out. And we're gonna start taking this player controls. And let's put that second. Let's make object ID always be first, if possible. So then, if the player is flying, client view physics, let's call that. Okay. So then, client view physics, do we run after we move or before move? I think we run before move. It was doing it the other way before, but physics, player ID, player controls, DT, float, player controls. Wait, player controls is this type, so I have to call that client player controls for now. Player controls, client player controls. And that gets passed into this as well. But it actually needs to be float control specific to that player. But we don't have that yet, so we just leave it like that for now. And then we compile to see which the things we need to, those things need to become out of that con thing now. Oh, and those are called buttons now. And what was the other one? Flying. Oh, yeah, there's another one there. Okay, so now we got to initialize that. So player controls goes into our thing. And player controls. Let's call it client player input. Controls is really a misleading word, so input. We don't need this now because we just put it up here, and instead this will live in main, and that's not externed, and that goes away. So now all those references to controls are references to this. So this is client player input. And then active control set should need to be changed. Ah, yes. Controls. Yep. Okay. Oh, it's right bullet. Okay. These become buttons. And I can't move. And I'm not falling. Even though flying was disabled by default because I no longer initialized it to the other thing. So somewhere I lost something. This is never being called. I never set it to valid when I allocate it. Dun, 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 dun. obviously hadn't run it in a little bit when I should have. Okay, so there we go. So now, still all I've done is refactor a bunch of things, but now it's so much closer to how it needs to work for the network, because now this is purely functional. This is not purely functional. It's accessing some globals. But that's okay because this is very explicitly the thing that's used only for the client. This is 100% server only if we want, or physics cache only. So that's totally ready for this code to be run by the server. And that client player input can be passed in over the net now. So let's go ahead and commit that. Yeah, see, this isn't as good because now I lose all the color highlighting. That makes it way more readable. I mean, it's also a terrible font, but the color stuff is actually nice. So I actually prefer to do a proper diff. Think of it's all just refactoring. Okay. Maybe do a little bit more. Like I said on Twitter, I'll just keep working on this every day till till I actually have something networked. You know, over this weekend, etc. And the implication of that was, yes, it's not going to get networked tonight. So I'm not going to kill myself tonight trying to get more done. So let's see. What else do we need to do here? So I want to fix this DT's crap up. So I'm going to just go ahead and continue passing it around just in case. But I'm going to change the logic where we generate these. What is it called? Process tick raw. Well, change the logic of this so we only ever pass in that. So the way that works is float pending DT. We add in the pending DT. We do that, and if we get here, we do that. Okay, and now basically this should be unchanged. It's just the fractions of a 60th of a second don't get processed till the next frame, and I obviously have a bug because I just went really, really fast. But I only ever call process tick raw with that anyway, so how would that happen? Oh, that needs to get zeroed. So I'm not sure how that could cause that behavior. I mean, that was clearly the bug, or a bug. But I'm not sure. It's a little odd. Like, so clearly this just kept accumulating time, and so I was doing a lot of processing per frame. But which is why I like instantly fall to the ground, and I'll instantly move when I tap the thing, because it's basically running a huge, huge number of physics frames now. But that is clearly I'm moving too fast, so it doesn't fit inside a collide region. But how can I be moving fast? It should just be processing lots of frames. It shouldn't actually be able to move faster because it should just always be moving by DT. So, and the whole point is that that logic, that's interesting. I forced it here as well. That's probably debugging that I need to get rid of. The whole point about this is that logic is obviously incorrect. And so I'm going to drill down into why, when I had that bug, it has that behavior. I need to understand that. And I want to see here. So here is the article on why I'm doing that. This is I think this is the right one. And I'll paste that into the chat. Yeah, so of course one day we're testing things and we see occasional flash of a crack or a sliver. This is pretty much an all-day stop. So anyway, you don't have to approach it that way. You can say, well, I fixed the bug, move on. And I'm not going to say that's the wrong way to do it, but my preference is generally, not always, but generally, that if I don't understand why the bug exhibits the behavior it does, if it seems contradictory, I mean, if it's, you know, if it's, I don't know how that bug would manifest, and so that's the behavior it has, that's fine. But if I think I know how the bug should manifest, and it manifests in a different way, then it's worth investigating to find out why. And it may turn out to be nothing. Like in this case, it may turn out that something in the physics is in the client physics maybe is updating something in a way that breaks stuff. But knowing that might be useful. So we have a z velocity of -110. That seems kind of high per second. That would be a pretty high fall rate. But how did we get into that state? That's the problem. DT is a 60th of a second as expected. Velocities, where do we increase our velocity? Oh, that's always in the fall code, which is player physics, which is this code right here. Always scales it by DT. So something in this logic, and in this particular case it's important because like I want the physics to be able to run, you know, if you captured the network stream and then fed it to the server, it should be able to run the physics logic faster than real time just to process it and decide what would have happened. And that's effectively what I'm doing here. That pending DT is causing me to call process tick raw over and over and over per frame. And there's no reason that that should blow up. So most likely it's because I'm violating the rule that the server is only looking at the server data, not that there's a server here. But it's also possible, you know, maybe there's just some actual reason for it that I'm not thinking of that's legit, that like I could input the right set of inputs in the normal runtime and have the same behavior. I don't know what behavior I could do to do that, but maybe there is something. Seems unlikely, but it's possible. Because this is running in a pretty different way because it is holding these keys down and maybe it's trying to rotate multiple. I don't think so. Yeah, I don't know. I don't know how this happens. Fortunately, it's super repro, so I can start over and try again. I just don't know how to breakpoint to catch it. Yeah, so that was outside the collision geometry. So maybe what we do is if Oh, velocity dot z is less than negative 50. And 3. There we go. So we got it to happen. So now what we're going to do is see if we can see what's going wrong. So we thrust in a particular direction. What is that one doing? Oh, I see. It rotates 2 of them, but doesn't rotate the 3rd. The up and down rotation is not. Yeah. We accelerate the velocity by the dt. Velocity is non-zero, so now we apply some friction to slow it down. And this slows it down a little bit. It goes from 57.3 to 57.2. And that's 60 times a second. So if you kept slowing down by 0.1 60 times a second, that would slow down by about 6 in a second, which is a pretty reasonable amount of slowdown, I think. And now we proportionally redistribute it, and now our z is down to negative 50.17. So it's still over it. Okay. So now the tricky point becomes this. We know almost certainly that this is going to fail and make us fall. And the question is, why is it failing? So we gather our collision geometry. We're falling. Okay, now so the question is, why are we falling? Because we have this incredibly high z velocity. So it keeps thinking that we're falling, but we never actually fall. It seems to be the case. Is there a path through here where z does not get added with dz? Is there a path where we don't return the z value? Oh. No, we update with z with the z value. So z dz. So we step down further. Now we're down at 8. We're way under the ground. So why did that one fail? Okay, so this one returns 0. We don't hit anything, which is wrong already. Because we're z0, z1. Oh, we're outrunning our physics. That's why. We're going so fast that the physics data hasn't gotten loaded. I bet. That would be my guess. Right, we had that whole thing about what to do if the physics cache is found bad. So let's try that. Although you'd have to go pretty far to hit that. Well, okay, at the very beginning. Okay, now it shouldn't ever do that. Yep, okay, we managed to move so fast that we didn't get a physics chunk built. This seems odd, but okay. Because the physics chunks are 64 by 64, so you'd have to move 65. Yeah, alright, anyway. So, okay, that's why that's happening. That's a known issue that I knew was an issue. I didn't realize it would cause that problem. So what was the problem? The problem is that gather collision geometry is bad. It causes us to fall through the floor. If we fall through the floor so fast by the time we're falling at the bottom, that seems odd. Let's try setting our initial position. Is that in here somewhere? Yeah. If we set our initial position really high, do we just have that happen? And then let me fix the pending DT. If I have to fall that far, at the bottom, am I falling so fast that we trigger that case? No. So I don't know why that happens. Still, it's a little odd. Maybe falling off the bottom edge of the map. Maybe that assert wasn't what I thought it was. Maybe that assert was asserting that the chunk was off the bottom of the map. No. Oh, but the gathered collision gets culled to the bottom of the map. Okay, this is... So we actually have to allow for the fact that Z0 and Z1 might go outside of the collision geometry. I don't know why it didn't just do that right now when I just set this to 350. Why is my Z position off the top of the map not trigger? Oh, okay. It just has empty data, but it does set the Z up there. So then, does that not apply when I'm under the ground? No, it doesn't have an assert there. So I'm not 100% sure I understand what's going wrong there, but I think I'm okay with knowing that there is an issue with that stuff. Knowing that there is an issue with that, I'm okay with leaving that bug unresolved, with that bug being a bug. I mean, what I'd like to do is change it so that doesn't assert. I guess I can just look at what the values are when it's asserting and try to really think about why that could happen to try to figure out how to fix the assert. Oh, I ended up under the ground. It loaded, it let me in under the ground, and then it loaded, and now I was under the ground. There we go. So Z of negative 315. Is my Z really that low? No, that my DZ is that low. No, my Z is that low. Okay. So yeah. Yeah, it's definitely trying to access outside. Yeah, I don't know. I don't know. If there's a real bug there, I'll wait until I actually find out. All right, so can I squeeze one more thing in here? Where was I? Yeah, I was just fixing that so that now we have we only call one. There's only one time value that we ever pass into the physics. But I'll leave it that way because it's possible I could always have single player mode, could use a larger DT and get a little extra performance in that. So I'll leave the DT being passed in, even though it's a constant. And it's also possible that you could do something where it's like, oh, your velocity is high, so I'll subdivide the time step, the fixed time step, to a different fixed time step. I wanted to get rid of that line. So what else do we have to do? Authoritative physics. So we're passing the control values in. We have our own physics generation someday. I think that's really everything the server needs. So, I guess we need to push you up out of the terrain if you do manage to somehow make that happen. Well, I started yawning a little bit ago, so I think I better just stop instead of doing something dumb. So, thanks for watching the stream. I'll check it in and commit it. Not that it's useful to anybody. And chat, I will be read over for questions. So, see ya next time.